18.4 MTOEs in 2030. Again, most of it is biomethane, depends how much of it will be used in transport. And they can go even higher to 23.6 if we add Annex 9 Part B biofuels. And then technically, they say there's no problem to expand this capacity, including concerns for feedstock availability, to 3 times larger and reach 57.7 MTOEs in 2030. But this needs, of course, the support of the market and of the policy. And the 3 bars there, the orange and gray, are for the current 2030 and 2050. Next slide, please. Then we checked on the biomass potential based on eligible biomasses on Annex 9, Part A and B. And we tried to do 3 scenarios and the technical potential. The technical potential is quite high, is from 1,600 to 1,800 million dry tons for 2030 and 2050, but then depends how much you mobilize. And depending on the scenario, low mobilization, high or medium, the high was not more than 50% and the low was 15% mobilized. So we see that we have 135 to 360 MTOEs available for 2030 and 294 to 127 to 390 for 2050 MTOE. And then we see that the largest potential comes from primary residues, from arable crops, from manure and stem wood and primary forestry residues, but we can also exploit the solid agricultural biomass, even for the low mobilization. And in 2050, we see that lignocellulosic crops become more important, and oil crops that are produced in unused degraded lands and cover and intercropped in combination with normal food are also more important. And this I'm saying because the delegated act now includes in Annex 9 Part A for aviation, intermediate crops and degraded land crops. And then there are many ways to fill the gap, but in the central scenario with the red, we have a gap of 10.6 MTOEs. And this we can fill it mostly with advanced biofuels, lignocellulosic, but also with some waste-based biofuels. And what we saw that we need to increase the synergies between the biological and the non-biological origin renewable fuels, because they work together well with the biogenic CO2 and renewable electricity that can increase the resource efficiency and can produce higher amounts of biofuels. For both pathways, this is something which is beneficial. And if you have a look there down, what will be the role of RFMBOs, looking at e-kerosene, e-methanol, e-ammonia, and hydrogen, we see that today only 3 to 4% of total RE2 transport target is covered by the implemented capacity, and the problem of availability of renewable hydrogen and CO2, which will not be eligible at the most after 2041, the fossil CO2. These are critical elements for the expansion of these RFMBOs. Next. Then how do we facilitate the technology deployment? Next. We have many instruments. We have instruments to support technological development, to demonstration, to industrial scale, pre-commercial scale, and we have loans and equity from the banks for building the plants. But looking at the Horizon Europe, we have in Pillar 2 Cluster 5, which is climate, energy and mobility. It has by itself 15.5 billion to support, including renewable energies and renewable fuels. Also other parts can support the technology development and demonstration up to TRL 8. Next. And here I show you as a brief coverage under the work program 23-24 for the renewable fuels and renewable energy. So in renewable fuels, we had both advanced biofuels, synthetic renewable fuels, also macroalgae for later on, and intermediate bioenergy carriers. And under international, we have energy-driven biorefineries that cover not only. In other actions, we have a study that now is under evaluation for implementing the results of the previous study, how to build actually industrial value chains. And under the Horizon Europe, we have a collaboration of InvestEU for SAF and the Breakthrough Energy Coalition, which is called EU Catalyst Partnership. And one area which this supports, it is called SAF. And we have something like 100 million every work program period that we put into this program from the Horizon Europe, 50% with the Breakthrough Coalition. Next, please. And here I show you the topics that are still open on renewable fuels. We have one on RFNBOs, synthetic renewable fuel technologies as area. We have the integrated biorefineries topic, which is also area, but this calls for international collaboration with mission innovation countries. And we have under cross-cutting market uptake. And this is an important topic, the market uptake, because it can reveal obstacles that we can work on them from the policy and the technology point of view to overcome them. And also, as I said, we have the study, which is under evaluation, and we hope to contribute a lot in the next work programming periods, and the contribution to InvestEU blending operation under the clean transition approach. Okay, next, please. Okay, I'm not going through this. Many people have seen the details of the energy-driven zero waste, neutral or negative carbon emission biorefineries. Many expectations there, but the idea is how we can collaborate again to bring the cost down, produce zero waste, and produce a socioeconomic and environmental positive impact, having all the assessments in place. Okay. Here, this is important. I wanted to show you how much we have supported sustainable aviation fuels from the years 2015 to the year 2023. We have put more than 200 million in 38 projects, and these do not include the very latest 2024 projects, but let's say cover all the 23. You see that depending on the year, but every year almost, we have money and topics in the work program that cover the SAF. We have spent it more than 67% of the budget to RIAS, but also 33% to IAS, Innovation Actions, Demonstration at large scale. And in Horizon 20, we spend the 60% of this budget, and the 40% is spent in Horizon Europe. But Horizon Europe is not over. It has 3 more working years, and we have a topic on renewable fuels for aviation, far advanced, and RFNBOs that has produced, I think, more projects, and that will add up. But you see substantial amounts per year from 2015 to 2023, and 38 projects in sustainable aviation fuels only through our program. I'm not counting here other support that could come from, let's say, the EIC or the EIT or the excellence part of the Horizon Europe, or even other programs like, I don't know, LIFE program. Innovation Fund is not included here. It is just Horizon 2020 and Horizon Europe. And some nice examples that have been already published. You see projects that have made it to the successful completion. We see the high flex fuel, which is a project for hydrothermal liquefaction to produce SAF and other projects there converts to synfuel. Bioplat is important because it shows the potential of the degraded and marginal lands in Europe for the new feedstocks. And you can find them in the Cordis presentation of results packs and click the link that it is there to access the publication. Next. More to the future on carbon negative fuels under Horizon Europe. Here is the idea, as I told you before, to utilize all the waste, even if it is CO2, and this can be combined and produce an RFMBO together with advanced biofuel. More information under the link of the info pack for REPowerEU for biomethane. And I have two more slides. One is on the Clean Energy Transition Partnership. This is also important because it provides extra support. It's a partnership that works like a big AeroNet. It has 30 plus countries from the EU and associated, plus international partners, and includes 50 plus funding agencies there. It's coordinated by the Austrian Ministry of Climate Action and the Swedish Energy Agency. And annually, we put 100 to 130 million from 2021 to 2027 for the calls. The calls include many modules, many subjects. One which is important here is hydrogen and renewable fuels. And actually, you can find more information through application to national regional funding agencies and meet consortium partners through the matchmaking platform, which is made. There will be a call coming now in 2024, and that will be launched on the 12th of September 2024. So please stay tuned and look at it. And there's been a pre-announcement, and actually SAF is one of the areas that is covered these calls as well. And in the next, I have some things about mission innovation. I have the director of the mission innovation sitting next to me moderating this panel. Kis is here. Thank you, Kis. This is another international initiative that the Commission participates and supports to push the integrated biorefineries producing fuels, chemicals, and materials together to optimize all the production and decrease energy losses, decrease waste, and decrease cost. Co-leads are India and Netherlands, and members are Brazil, Canada, the European Commission, and the United Kingdom. And we have knowledge partners that support us like IEA Bioenergy, Task 42, and others. And we have a work plan, and under this, perhaps the most important thing is to mention that we run a techno-economic study for the feasibility of sustainable aviation fuels. This is a collaborative initiative between Brazil and Canada. This is a model, actually, that is being developed by these two partners. It will produce case studies for more advanced and less advanced technologies, and we think that it will be a very valuable tool that will show where their possibilities exist in the various areas of the mission innovation countries to promote SAF technologies, and we hope more countries join into this collaborative effort. Next. Of course, the Horizon Europe is a possibility as well. And here are some useful links for those who want to know more about the topics or more about our work program. And next, thank you very much for your attention. If you have any questions later on or by email, you can always contact me. Thank you.
Thanks, Maria, for the presentation. If there are any questions for you or in the room, we're going to keep them for later on during the panel discussion. Then we moved. I'm very happy to see Ms. Christian on the screen. Ms. Sen, you have the floor.
So I will present you the Icarus project on international collaboration for sustainable aviation fuels. But before to start with that, I would like to say many thanks to Maria for all her efforts. First to provide us with the venue, and then for helping us out with this very complicated, let's say, web meeting. Many thanks, Maria. Many thanks to your team. And again, many thanks to Kyriakos that really help out with setting up the policy workshop, as we were discussing in the framework of Icarus, and for being responsible for all the eminent speakers that will make their presentations. And of course, last but not least, many thanks to Yasmin and Rainer, who provided with all the administrative assistance. So the next slide, please. I will say a few words about our objectives and the innovations we will use, and then the consortium and our boards that really are very helpful in working out with this international collaboration, because we wanted to have a strong international collaboration in this project. The next slide, please. All right, a few details about the project. That was submitted under the topic of best international practice for scaling up sustainable biofuels serviced by SINEA. The project has a three-year duration, starting from October 2023. So we are somehow in the first 6 months. Our budget is a little bit higher than 3 million. And we have the pleasure to have something like 20 participants involved. 14 participants come from Europe, and then we have participation from Switzerland, Canada, 2 partners from India, and 2 partners from Brazil as associated partners, in order to, again, stress out the international character of this project. The next slide, please. The ultimate objective is to develop best practices based on improved innovative technologies, and also concepts based on market access knowledge along 3 main value chains. The whole project is built on these 3 value chains. One is the biocrude oils to SAF, starting from hydrothermal liquefaction to the sustainable aviation biofuels production. The second value chain is from isobutanol to SAF, and the third chain is from syngas to SAF. As you see here, we have the collaboration of international associated partners in almost all tasks. Starting from the feedstock, we have the collaboration of India and the US. I will explain you later on how US is joining us. In the isobutanol to SAF, we have the collaboration of Brazil and India. And in the syngas to SAF value chain, we have the collaboration of Brazil, Canada, and the US. Finally, regarding the sustainability assessments, which involves all the techno-economics and environmental and social acceptances, we have almost all partners involved. The next slide, please. Our specific objectives. First, we start to evaluate the framework condition for SAF development in Europe and the mission innovation countries. We need to know where research is right now, so as to proceed with the scaling up scenarios that we aim to build. And the second objective is to improve the scaling up of selected promising technologies, as I showed you before on this selected 3 value chains in Europe and the mission innovation countries. And here we will focus specifically on technological challenges in each value chain that hinder further the market deployment of SAF. The third objective is to enhance the overall cost effectiveness and suitability by carrying out life cycle analysis and socioeconomic assessments. Then our objective is to develop future best practices and concepts along these 3 value chains based on experiences and lessons learned both in Europe and the mission innovation countries we have involved, and of course to set guidelines for scaling up and building synergies between industries and the scientific committee for that reason. And finally, of course, we have to disseminate and exploit our results into the general public. and the society and the scientific society, of course. Next slide, please. Very briefly, I will talk about you regarding the innovations we have, because it is a RIA project, Research and Innovation Action. So we are having a very strong innovative part in this. The first innovation pillar is the feedstock. We aim here to support sustainable, affordable, and diversified biomass feedstocks, and how we are going to do that is we will test several cropping systems of biomass sorghum with legumes and cover crops. And the overall objective, I can say, is that after growing those crops in pots and in larger field areas, to combine these mixed cropping systems, combine the biomass harvested, so that to regulate somehow the lignocellulosic oil and mineral composition of these blended feedstocks in order to fit better to the technologies that will be tested in this project. I will not get into these details. Please go for the next slides. The second innovation pillar is now we start with the value chain. So the second innovation pillar is the biocrude to oils to SAF. Here, the specific need is and the outcome is how to assure a nitrogen removal from the biocrude oil, so as to improve the biocrude oil's quality. And the technical novelty here lies in two steps. As you see, they are marked with green. One step is to test the nitrogen removal in the pre-treatment of the feedstock prior to the hydrothermal liquefaction. And the second step of innovation is to check the nitrogen removal in the hydrotreatment step. And here we are planning to create an innovative catalyst bed with blends of catalysts that will simplify this process by decreasing the steps, the energy to hydrogen consumption, materials applied, and things. So this goes from TRL3-4 to TRL5 as we expect to have. The next slide, please, is about the third innovation pillar, which applies to the isobutanol to SAF value chain. Here, the need is to engineer a secretion of cellulosic enzymes in second-generation isobutanol yeast to lower the enzyme costs in the biomass saccharification. So novelty here lies in the step in the step of the cellulosic enzyme engineering and C5 to C4 C6 sugar fermentation. So the main focus is the direct cellulose hydrolysis and C5 to C6 sugars fermentation, with the aim, of course, to minimize the need for expensive cocktail of enzymes. Then in the next slide is our fourth innovation pillar, that is in the syngas to SAF value chain. Here, the need is to test a new Fischer-Tropsch catalyst that will produce only liquid products, as you see in the slide. So the technical novelty is how to demonstrate this new FT synthesis that will significantly reduce the capex and improve the economic viability of this pathway. This new FT catalyst will allow the development of smaller sized plants, fitting much better with the local availability of biogenic residues. In the fifth innovation pillar, in the following slide, the next slide, please. Yes, it is on the sustainability analysis. The need is to secure a sustainable transition to large-scale use of sustainable aviation fuels. And the novelty lies in establishing a novel framework for sustainability analysis for the whole value chain perspective for sustainable aviation fuels that are at pre-commercial stage in order to facilitate their scaling up. The environmental analysis will take a future-oriented prospective approach, and it will be a model-based approach that will provide a basis for systematically connect all the processing stages that we are testing in the 3 value chains. And the next slide, please. This is our consortium. There are dedicated partners from the feedstock, the Biocrude oils, Isobutanol to SAF, syngas to SAF assessments, and the best practices that are working with that. And as I said before, we have also the collaboration of international associated partners in all these major technology steps. And I have, I think, one more slide. Yes, it is our external executive advisory board. The reason I'm showing this board is that this is the place where we have established the collaboration with the US. We could not have them as associated partners. So we have 2 representatives from NREL and from the North Dakota State University. They will provide us, they will contribute in the project by providing specific tasks on innovations in the innovations to the syngas to SAF value chains in core package 2 and the innovations in feedstock. They are more or less invited and fit to the technological developments that we are testing. Apart from those, we have a representative from FAPES and from the IEA Bioenergy on task 39 to help us out with building capacity in a global level. And then we have a representative from JRC, Marco Buffi, to work out with sustainability assessments as he's working already on the RED 2 and the ICAO CORSIA initiatives. And last but not least, we have a representative from CONCAVE to help us out with the coordination of our research with the oil sector. That is in brief what I wanted to present. And the next slide is thank you for attending this workshop. Can you please show, yes, for attending this workshop. And here are the codes. You can click, you can scan and click them and be tuned with the research and our results as we will be producing them. Yes, and if you have any questions, I'm happy to present. Apologies for not being there. I had a serious health problem and I could not join the meeting, but I'm at your disposal for any question or clarification. Thank you.
Thanks, Ms. Seni. Questions will be dealt later on during the discussion. And now we move to the next. After having seen more or less how the European Commission is trying to support the development of the technologies and having introduction to the Icarus project, now we move to more or less international environment. And we have Dr. Preti Jain from IATA. Preti, you have the floor. And thank you for being with us today.
Thank you, Mr. Kyriakos, and thanks to Ms. Maria from DG RTD, and thanks to Ms. Myceni for having us to present our view from the aviation sector. And I could also understand in the audience we have, various stakeholders representing the spectrum across the SAF value chain. I think that's what is needed when we are discussing the policy as well as technology landscape. Can I have my slides, please? And I'm representing here IATA, International Air Transport Association. And the next 10 to 15 minutes, what I am going to share about as an aviation industry, I think the policy landscape, which Ms. Maria has beautifully crafted. And on the technical part, we just heard why the role of new technologies and working towards in collaboration is important. From aviation industry, I must say we need each and every drop of that SAF in a cost-effective and in a sustainable manner. And what we are trying to do to make that happen as a, important stakeholder in this value chain, and what are the international commitments we are party to, I'm going to share that. I think this is the big picture. I'm sure, all of us have seen this big picture, but I just wanted to take a moment here. Because if we see, carefully at this pie chart and look into all the sectors, aviation is hardly a very small part of it. Just 2% of total global CO2 emissions are coming from aviation sector. But at the same time, I must also say, as an aviation industry stakeholder, we also realize that we have a significant growth potential and we are on a growth path in different geographies around the world. And the share, which is currently 2.3% of total CO2 emissions in 2022, that can increase significantly. So it's a proactive approach from the aviation industry to see and step up that how the growth in aviation sector can be sustainable as well as safe, and how sustainable aviation fuel and many other levers, who can help to bring this CO2 emissions down can work in our favor through different approaches. So looking into our commitment by 2050, ITA, I think all of you are aware, but I'm just reiterating once again that in 2021, we made a commitment that by 2050, we will achieve net zero. And at the same time, ITA also, stepped up to see that how the carbon neutral growth and enablers can be, followed in the process. And it's not an easy commitment given the fact that in the aviation industry is an industry based on operations. And if we look at whether it's a supply of aircraft, whether it is operations, whether it is our fuel supply, nothing is in our control. And we are always dependent on the outside party. And it takes a lot to, commit to that kind of commitment where we are together representing almost, major airlines. When I say major airlines, we represent almost 333 airlines across the world, which in terms of passenger traffic contributes to around 83% of the passenger traffic load. So this is basically to look into that, how the connectivity in future is going to be sustainable and we can mitigate the carbon emissions from the sector. When we look at what is needed to reach this net zero 2050 target, there are different levers, which I think many of us have just not touched, but I will just go through in holistically. If you look at this pie shows, different levers which are needed to reach net zero target by aviation industry. And though the blue color is pretty dominant in this picture or in this pie chart, but I must highlight the role of offsets, the role of infrastructure and operational efficiency, and the role of new technologies, which is nearly close to 40%, less than 40% on this pie chart. That shouldn't be undermined. And we are, discussing about research and innovation in this session and how the role of policies and technology players is important. And new technologies very much fall in that place where we need to have a continuous stream of policy as well as funding support. Now, coming more specifically to sustainable aviation fuel, because when we look into 2050, commitment and how we can reach there, almost 65% of CO2 reduction we expect that will be met through sustainable aviation fuel, which is some of, technologies are already commercial at a scale. And this is a very practical solution because of a drop in fuel and which is fully fungible. And given the infrastructure requirements at the airport, this is an opportunity which I think allows the airline industry to meet the target. But the challenge there lies is that when we look at the SAF production today, and I will get into the fine details in my subsequent slide, it requires almost 800 to 1,000 time increase in the production from where we are. And the question comes are how we reach there. Definitely, we need strong and urgent policy support, but we need technology also, and I will come to that piece of it. We also realize that, 2050, many times we see, 2050, 2070 commitments are a long-term commitment, but we are, as an industry, we are working with governments around the world, and we are trying to break those commitments into implementable and practical targets in the near term and in the midterm. So third conference on alternative aviation fuel, which is CAF3, which was held last year in Dubai. And during that conference, the government came together and aviation industry was also one of the important stakeholders at the event, coming together to make a commitment that 5% of the CO2 intensity, CO2 emission reduction will be brought into the sustainable aviation fuel as well as low carbon aviation fuel known as LCAF by 2030. Why it is needed? The question comes there. because as an industry, when we look at our emissions in 2030, it will be around 682 million tons of CO2. And if we want to reduce those emissions, it will be required that sustainable aviation fuel and LCAF, low carbon aviation fuel supply should be there. And they will be contributing to around 34 million tons of CO2 reductions, which will be corresponding to the 14 million tons of SAF if you look at this slide based on the numbers. But how we are doing there? That is the SAF which is required by aviation industry to meet 2030 CO2 mitigation targets. And when we look that target from a different lens of policies and airline commitments, airlines have been very proactive in this space to come forward, make a commitment in terms of offtakes, in terms of uptakes, and also some of airlines, I must say, are pretty positive going ahead even to be a party of various SAF technology-based projects. And when we look into my right side, we see that 64 airlines have announced voluntary commitments and signed into various agreements. And when we take that amount together, it stands around to 20 million tons that will be required by these airlines. At the same time, as Ms. Maria also highlighted, that policy is a very important enabler. And when we look into policy landscape around the world, the policies, whether in form of incentives or mandates, will require producers to bring in around 17 million tons of sustainable aviation fuel. So definitely from supply side, from demand side, there are commitments, there is guidance. But how things are moving on the ground, that is the real question. So at IATA, we also track different renewable fuel capacities across the world, which are going to be online in the next, midterm and long term, and especially in the 2030 timeframe. When I say renewable fuel capacity, it includes SAF, but all of them are not SAF. But at the same time, I would also like to clarify that they have an ability to produce SAF as a part of their product slate, provided there is clear and tangible policy guidance. And I will come to that in a bit. We see that, renewable fuel capacity around the world is expected to reach 51 million tons. But at the same time, when we track these projects, there is movement, lot of announcements happening every other day. I think all of us are looking into these announcements. But when we dissect these projects and look into the real progress on the ground, I must admit that we see very sluggish pace of movement on these projects to the commercial scale, which is needed for industry. And yes, government financing is very central for the progress of these projects, and we see a mix of incentives and various other policy instruments coming up. Taking a bit deep dive into these projects, and we took these projects around the world and put them into the regional landscape, as you can see in the bar chart on this slide. When we looked into these projects around the world, it's distributed in different regions. You can see that the capacity distribution as well as the number of projects. And we see that the dark blue, which is indicating the capacity, Europe and US are the leading regions which will be, emerging in terms of having the renewable fuel capacities around the world. At the same time, another interesting part I would like to highlight is when we look at the Americas and Europe again, in terms of the number of projects, we see Europe is leading in terms of number of the projects, which definitely shows us that in the efforts and the policy guidance to promote research and innovation is pretty high in the region, and number of projects to have all the technologies getting an equal footing in terms of, expanding and in terms of research and innovation is pretty significant. But at the same time, I must underline that is important, but taking these technologies from pilot scale or pre-commercial scale to the real commercial scale requires billions and billions of dollars, and where we need more policy push and incentives. And on the pie chart, if you see, we see that HEFA, which is a commercial pathway today, represent nearly 78% of the total SAF production, and it is going to remain the same if we don't bring in research and innovation much more, proactively on the forefront, and not just bringing into a pilots up to it, these projects up to a pilot scale, but further taking these projects into a commercial scale. That will be the real success of, taking research and innovation to the commercial level. Because at SAF, for the production of SAF and to meet aviation industry aspirations, we need not only feedstock diversification, but also feedstock rationalization. When we look into different feedstocks, we put them into 3 different baskets, what it is available today, and HEFA and renewable diesel capacity and SAF swings. Definitely those kind of developments are very much available in the market. But I think speakers before me definitely highlighted that we need to diversify feedstocks and we need to bring in new technologies where we see alcohol to jet, which use sugars and carbohydrates, are going to provide more SAF availability backed by research, innovation, and policies. And waste, which is in the form of biomass or municipal solid waste and others, I think syngas and Fischer-Tropsch is important, but at the same time, bringing hydrothermal liquefaction and other processes will also help, because then we can channelize all of these waste feedstocks into a intermediate energy dense product and then converting into SAF. So definitely SAF requires all the feedstocks and all the pathways. I must also underline, I'm sure many of you are aware about this, but I think for many of us at the same time don't understand that all SAF pathways don't provide SAF in the equal percentage of their product slate, where again, role of policies and guidance is very important. For example, in US, I'm taking example there, has many renewable diesel and SAF plants, but for these plants to swing into higher slate of SAF or increase the SAF production, some of them can go up to 50% of the SAF production, but they need policy guidance and the pricing, of the SAF and the incentives so that it makes a good business case for them. Similarly is the case for gasification. By default, it produces around 15 to 20% of SAF, but I think with the cracking and as well as various isomerization processes, you can increase the yield. But again, policies, incentives should make a business case for these SAF project developers. This is, I think, my last few slides. I shared about, different technology pathways and, our commitment as an industry. And when we look at all these 140 projects around the globe, what is the difference between aspiration and actual progress on the ground? The difference is great, as you can see on the slide. In 2024, as compared to global jet production of around 285 million tons, the SAF production was very, small, just 0.53% of the total jet fuel share, which is 1.5 million ton, as you can see on this slide. And when we look at this production in terms of the percentage share from total renewable fuel capacity around the world, SAF was hardly 6% of 51 million ton renewable fuel capacity around the world. So definitely policies is there, innovation and research focus is there, but we need more economic and financing instruments so that it makes more value proposition for these units to increase production of SAF. And policy is definitely as an enabler. I think you guys are sitting in DG RTD, so I know that's a hub of policy. I won't go into much detail, but I think when we step back and look at the bigger picture, an effective policy framework is necessarily an enabler for SAF production, and taking that into further stage of commercialization, predictability and stability and technology neutrality, I think all of us have been highlighting since the beginning, and we can see different technologies getting a great, opportunity under policy landscape in Europe and different parts of the Europe world. I must also said that various practice in terms of accounting are equally important, especially role of book and claim. I was in Africa last week, and we see a lot of potential in the region. But the question we were getting in that region was, if we produce SAF and we don't have demand, what we do is, so answer there lies in book and claim. And at a policy level, I think we need all solutions on the table, be it mass balance, be it book and claim, to unlock the potential of SAF around the world. And consistency of policies is the key. And it is also important that these incentives are stackable from an airline point of view, so that the environmental attributes of these SAF, which are required by airline members, they can really avail them to meet their obligations. Last slide from my side. I won't go much into the details, but just say we need both policies as well as mandate mix. Definitely, sometimes we see, either a region going one way or others. But we must step back and look into how renewable, especially solar, came into existence and reached today. Incentives play a very important role in the growth of solar or wind renewables. And same is needed for the SAF, because we are looking for a functional market. We are not in a market which is mature, we are in a nascent market, which are still trying to walk for the research and innovation. And definitely incentives should come first till the time we have a functional market. First of a kind plant require more financing support. And yes, then mandates can also have a role to play. So a balanced approach definitely is required in all these paradigm. And these are the last slide to leave the message that what are the important ingredients we need. All levers are required in terms of priority. Investment has a very important role, whether to support the research and innovation, which we are going to through Icarus project. And incentives are important for feedstock expansion, at the same time having new technology-based project. I must also underline that when it comes to incentives from an airline industry, when you look into all these grants around the world, there are very few grants which looks into how the airline industry can also avail those grants. And I must say, and congratulations to DG, that under SAF allowance, we see there is one funding mechanism which will be applicable to airlines also for help them adoption of SAF. But one scheme is not good enough. We need many more schemes like that targeted for aviation industry as well. And we need innovative accounting mechanisms where book and claim can open many doors for SAF production. And as an industry, we can have accelerated production of SAF. So I will stop there. Thanks for the opportunity. I will be happy to take any questions. Thank you.
There was a question.
You're muted, Kyriako.
It should work. Sorry.
Okay now?
Yes,
Well,
okay.
thank you, Dr. Jane, for the presentation. You ended up very nicely discussing about the key enabler is to have an effective policy framework. And that puts basically the next presentation very much on focus, because it's going to be given by Mrs. Eva One from DG Move, who is more or less leading the Commission's work in this area. Eva, you have the floor.
Yes, hello. Good morning, good afternoon already. So this morning the presentation is as you introduced on the policy, and I'm from Director General for Mobility and Transport, leading the Refuel EU Aviation Initiative. So I would like to give a bit of policy background for developing SAF and what are the focus and the pillars, how we see it. So if we go with the next slide, so first starting with the political priorities, we are well aware of the European Green Deal, the flagship of this college for Europe to become a climate neutral continent. And here where we fit from the mobility side, it is translated and implemented through the sustainable and smart mobility strategy, which looks very much on the different modes of transport and sets that all modes of transport will need to contribute to the decarbonization to this objective. And in implementing of this smart and sustainable mobility strategy, we look how we could, what the contribution could be from the aviation sector, and what we see is we are familiar as well with the basket of measures where aviation as a hard to decarbonize sector will need to have different levers to reach this ambition. But among them, we see the SAF is the one which can offer solution in the short and long term. And if we look, if we go into the next slide. Was then in that context, we have developed the Refuel EU Aviation initiative. Yeah, I don't think I can change the slide myself. So if we could, I still see the previous slide number 2. Yes, thank you. So, with when implementing the sustainable and smart mobility strategy and looking that SAF is the vehicle for aviation to delivering on reductions from emissions in the short, but also will stay there for long term. We look at the instrument how we can bring this big energy transition in aviation happening, and so the SAF is a nice solution, but there are a lot of challenges we've been discussed this morning. There are still high. There is only this one HEPA production pathway which is mature, but the rest is still needs to be more technologically and commercially matured. And in this context, we see that we had so far more generic policies which didn't bring any significant volumes to the market at the time of developing this proposal. So for example, we have the general targets for transport, renewable energy in transport and the Renewable Energy Directive, which help to steer renewable energy in the road, but didn't materialize for aviation as those more processing steps are needed and those fuels are more expensive. So this sector went for the low-hanging fruits. As well, we had, I think it was like in 2010, there was also the strategy flight pathway or something in that way that was also setting a vision that aviation should have 2% by 2020. We should have already 2% of SAF uptake, and so also this has this aspirational commitments also from the sector. It didn't allow us to break this chicken and egg problem of the supply and demand, how to kickstart the production of SAF. And once you have sufficient volumes, you can bring the cost down, and then you can make it affordable for airlines to uptake, while the production says there is not enough demand and uptake to start production. So with those considerations were very important, how to have a dedicated measure to overcome those challenges, while at the same time looking at the particularities of the aviation market, because aviation market is highly competitive. We have a high integration within internal market, but as well it's the global operations. So this also in mind has to be taken in developing any measures the international competition of the sector. So when we looked at the mandates that we've been developing for the supply of the SAF, important the regulatory framework was important, that it provides uniform rules which can be applicable across all member states, that it is easy to implement, as this is a new change for the sector, new transition. So as well to make it easy to apply and to fulfill, to give also this long-term certainty and visibility that is also very much stressed by the investors, that they also, and as well in the previous presentation, that this long-term horizon, because the investment is at least 15 years. So you need to have this vision, and as well to buffer sufficient flexibilities sufficient transition periods, as well to facilitate as much as the transition, this energy transition in the sector. It's not the purpose to give the extra penalties and taxes. That's not the instrument. The objective is to stop this vicious cycle and to bring SAF. But as well, then it's very important this constant monitoring and where we are, and we will have the starting from next year annual reports from EASA, which will look at the status of the market. This is something we are already working, so we already see some as well figures which were also from IATA presentation. There were some interesting data. We also have the focus on the Europe. So this is something we will be publishing annually, and then already the revision from the Commission will come already after 1 year experience of the mandate. So because as this we are creating new market, it's very important we are agile and we keep close monitoring the market, what works, what doesn't work, what can we improve. So if we look, if we go to the next slide, we have there more deep dive into actually the most important components of this regulation. So those are overall 2 objectives. It's the decarbonization aviation through the scaling up of SAF, while implementing in a way that will give the same conditions, same rules for all the operators in the EU, so to creating level playing field. And the main feature is this supply obligation, which is dedicated for the SAF with a dedicated sub-mandate for synthetic aviation fuel. And this is because those fuels have the highest challenges to realize, with the highest risk, highest capex. So to give the dedicated incentive, and the sub target only enters us from 2030, and then it builds up. The ramp up starts slowly, building up quickly. And also, as I mentioned, that we have already some intelligence from EASA looking, working for the next year report on the status on the SAF production. So what we already see is that for the mandates in the horizon of 2030, we are good on track for 2025, 2030, with the capacities already in place, and with the ones which are under construction, that should allow us to meet the targets as concerns the biofuels. However, what we see for synthetic aviation fuels, those are still not yet coming fully to the market. So there is still a bit more time. But the final investment decisions would need to be concluded in the next 1-2 years latest, actually to fulfill. As well, from policy perspective, very important for us is to keep this predictability and stability. So to keep the level of ambition, exactly to incentivize those investments. So that is as it concerns the regulatory framework. And then I would like to a bit focus on the next slide in a big broader picture. When we looked based on the impact assessment, what are the impacts as well of transitioning to SAF with the level of ambition at the level corresponding to what I presented on the previous slide. Because we always speak about SAF in the context of the environment, notably emission reductions for the GHG emission reductions, but as well it has benefits around the airports to reduce air pollution, and as well SAF has a lot of potential for the socio-economic perspective to bring new jobs, new plants. So for example, we see we will need much more than 100 new plants to meet the ambition of the 70% blending by 2050. Another potential benefit of SAF is that SAF can be produced from various type of feedstock and processes. So this also gives opportunity to diversify the supplies. But here, of course, the support from innovation and R&D is very important actually to allow and to support bringing those new production pathways. And maybe as well, always what is very important for the sector is the impact. So based on our impact assessment, which also, of course, embeds the increase in the carbon price, and the price of fossil would increase over the time, while the increase in volume of SAF will help to decrease. It didn't show very substantial increases for the ticket price increase based on those assumptions in the impact assessment. I would like to as well, for the next slide, this illustrate and also echo the previous presentations that the comprehensive approach is needed. It is a complex transition. We are introducing the new type of product, which with high risk, which require a lot of capital, and different type of still risk on the both on the revenue uptake side as well on the technological side, on the feedstock side. So there are different risk related. So that's why we need a suite of measures. So we have in the left corner the regulation which I briefly introduced, which will help to give this long-term market certainty and will help to bring lead to the new projects which we see that they have started to appear on the market. However, we also have projects to support collaboration in value chain. So, for example, we have the Alliance, Renewable and Low Carbon Fuels Alliance, to build the partnerships, to build the networks, and to look at from industrial side, what are the bottlenecks, what are the solutions. And then as well is important are the instruments to support on both sides, on the production side, so to de-risk, to make the project bankable, so from the financial side, but as well from the operational side, initiatives to reduce the red tape. So as we have mentioned before, the Net Zero Industry Act, but as well initiative which we are working on is the SAF clearinghouse. So this is an initiative which also will help to bring innovation to the market, to the new production pathways, to help SMEs to bring those new production pathways certified. So it's more a support as well from the process and operational support. And on the side of the uptake as well, so we mentioned that the SAF allowances under EU ETS, which can in the transition period can help to narrow the price gap and also make the travel more affordable, preserving connectivity, but as well other tools like for example the proposal for under energy taxation to tax higher the fossil fuel and the treat preferably SAF can also help to narrow the price gap. I have listed in the next slide, I have these boxes. Yeah, if we can go next slide, there are basically those boxes, this support measures clustered along cooperation, production, and uptake, and clustering the production and uptake through the financing and through the operational measures. And I mentioned a couple of them, but yeah, so the main message is indeed we need a comprehensive support, and so policy can help to steer the direction for the research and development, but research and development is a key enabler actually to do the policy, because without the research and development and without actually help to bring and have those SAF, we would not be able to have those regulations and those policies. So they need to be very coherent and supporting each other. So with this, I stop here to allow time for discussion. Thank you.
The panel discussion with Kees Kwant from the Dutch Enterprise Energy Agency. Kees, he is very well, how can I say, known in Europe. He has been involved in IEA Bioenergy, now with Mission Innovation. Yes, you have the floor now and to lead the discussion.
Okay, thank you very much. Yes, thank you very much for the invitation to moderate the discussion here. At first, I was a little bit surprised. So why do these Greek people call this project Icarus? Because in my knowledge, what I learned is that Icarus at the end drops into the sea. Yes, so it was not a very successful flight. But then I thought, okay, that's why they asked the Dutchmen to solve this, because we say luctor et emergo, which means I struggle and I will come up out of the sea. Yeah, so that's, well, I hope together we can have a very nice discussion about, let's say, this project Icarus. Because what I see, and I think also from the presentations, there is a lot of ambition. Yes, we want to achieve a lot. We want to lot. There are also a lot of possibilities, and at the same moment, we are also a little bit struggling, everyone, to see how can we do that. Yes, and that is a kind of question to everyone. What is the next step? Yes, how can we trust each other in this path to this very big ambition so that we can develop, so that we can invest, and that there is enough funding to make it possible. So I think that's the feeling that we all have, that we are on this edge of trying to move forward. So I'm also the director of the mission director of the Integrated Biorefineries Mission. There we're also looking into this topic of how can we use the bioresources in the best way. And one of the ideas we have there is to look at it in an integrated way. So to use the bioresources for fuels and also for chemicals, and try to valorize the resources as much as possible. And this valorization through, let's say, economically, but of course also environmentally, yes, so that we can get the highest greenhouse gas reduction possible. But today, of course, we are focusing on the SAF, so on the sustainable aviation fuels. And I think what I've seen here is that, yes, we are implementing, we are now at the half percent, yes, of replacing the fossil fuels with SAF. We want to achieve, 6% in the year 2030. So that is already a lot. We have technologies, that is HEFA, but HEFA, of course, at the end, based on used cooking oil, it's also final. So we need new technologies. So I was very glad to see that the Icarus project is looking at different technologies. And so that's also now, let's say, our discussion, research and innovation. How can that help to facilitate market uptake? And so that's actually my question to the panel. First, I would like to ask the panel, okay, how do you see that, let's say, research and innovation with these new technologies can bring down costs? Because we have the HEFA-based technology, then we will have to move to new technologies. But of course, for the aviation sector, they want to see cheaper fuels rather than more expensive fuels. So how can these new technologies, and you mentioned like Fischer-Tropsch based or ethanol based, different technologies are there. So how can they offer cheaper solutions and how can we realize that together? So who of the panel may I give the floor? There are, let's start with Mirsini, because you are, let's say, leading this Icarus project. So how can this happen that we can facilitate SAF market uptake with these new, let's say, fuels that will be developed?
Thank you, Kees, for the question. Indeed, that was the very first question when we decided to build up this project. And before I start, I have to say that I received the very same comment on Icarus from another Dutch guy who wrote, but Icarus finally dropped down. So what kind of project is that? So we thought that we will use the technologies, and this time we will make Icarus fly. And we were very lucky that we received the funding of this project. So finally, I'm pretty sure that we will make him fly at the end, after all these thousands of years. So coming now to the technologies. First of all, we selected 3 value chains based on the feedback from the partners involved, because we consider that these value chains lead to commercialization of the feedstock. They are the 3 main value chains to produce SAF. So we thought these value chains can easily scale up. So what is the technology burden, and at which step, and how we can move on? What kind of technology challenges should we take into account? Should we focus on our research so as to facilitate the market uptake of SAF? And we selected specific steps, as I showed you, in the biocrudes, to help with the quality of the biocrude oil, and in the Fischer-Tropsch synthesis, for instance, to make this specific research on how to produce only liquids as a final product, or in the alcohols to jet work out with catalysts and things. So we believe that this specific technological burdens or challenges that we face will help us. If we solve them, we will end up with a product that is cost efficient. Coming now to the feedstock, that is a very big question mark. Apart from using the residues, we thought that we should also put more research on how to produce extra biomass. At the end, it will be more like assuring extra biomass needed for scaling up the feedstocks. And we selected this kind of research that we have seen in the past that really leads in doubling or even tripling the biomass production. So I'm not the end in all this framework, because it was an international approach. We have selected those partners from the mission innovation countries that really help us out in these specific technological challenges we are working. We have Indians working with the same feedstocks, and then we will exchange information on best available varieties and best available techniques to grow them. We have included them in the 2 value chains, where they will also have pre-treatment tech and other tests, technology tests in their laboratories, and then we will join forces in order to achieve this cost effectiveness that we aim to. Okay. I'm not sure if I replied you.
Thank you. So I think that this looks promising, yes. So to realize reduction of costs through, both ways, technology, but also looking at the supply side, the resources that can be used. So then actually the question to Preeti is when let's say the aviation sector, yes, you are also looking to SAF fuel. So how important is it for you from how it is produced? So is it the technologies that are behind it, the resources that are used? Does that make for you a difference, or is it for the aviation sector? You need so much that you will pay whatever is available.
Yeah. So, I would take a step back and look at the bigger picture in terms of, different technologies, different feedstocks, but at the same time, I think I would also like to comment on one of the point, I think you mentioned on the expensive fuel or cheaper fuel. I think making. Can you hear me?
Yes, we hear you. But,
I hear some background noise.
Thank you. Yes, you can speak again.
So sorry, I said you also mentioned about cheaper fuel or expensive fuel. I think it's not about cheaper or expensive. It's a question of that price parity will only come when there is a balance between supply and demand. And today we don't see that balance. So the price of 5 or 3 or 4x what we are seeing in the market is not the true reflection. That's why we need research and innovation and diversification of feedstock and technologies, so that SAF production from multiple pathways can happen. And I must also say, one technology and one feedstock can be very specific to a region. That doesn't mean that same technology and same feedstock will work for different region. Till the time before coming to Europe, I was in India. So what business model in terms of feedstock aggregation and technology promotion works there may not work here. So I think we need to find a tailor-made solution for every regions to promote different technologies and have SAF production. The other point I would also like to say is, which I highlighted in my, presentation also, and taking a step further, we see a lot of, different regulatory language in different geographies. And whereas aviation is a global industry, I don't think, regulations are different for the international carriers. They are very similar. So probably at a policy level, we also need to have a very, similar, harmonization of the policy language and regulatory compliance. And we need to bring the best practices like book and claim, I would say again. Some regions are very much rich in feedstocks. How you bring the environmental attributes of those feedstocks in the product and aviation industry can take benefit of it. Because for us, in SAF is important, but more than SAF, the life cycle basis benefits of CO2 on a LCA basis of that product are also equally important. So it is good to craft low carbon intensity feedstocks, supply chain, so that, the environmental benefits which we are really trying to see in SAF, that can be delivered. So I will stop there.
Thank you. This afternoon, we will continue the discussion about policies. Now it's really about research and innovation that is needed to realize a good market for aviation, for SAF in the future. So I've asked some questions. So maybe there are some questions in the room, in this room or in the digital room. Are there any questions? Not right now.
No.
No.
If you wish, I can also give some comments
Yes,
from
please.
my side, from the policy perspective. And when we were developing the impact assessment, we looked at the prices will go down over the time from two drivers. One with the scale up, with the basically if the more volumes in the market, it will allow to create this market. Currently, we don't really have a liquid market, so the prices are very high and not very representative transaction by transaction. But as we have the more volumes, this should improve. But as well, then the second driver is to improve as well the efficiencies. And here definitely that's a role for the research and innovation on that side. And important that the research and innovation is supporting from the all stages of the life of the fuel. So from the very different stages of the maturity of the project. So to help with this continuity, and whether we are starting from the feedstock, as we said, how we can get more out of given input, bringing the new pathways that we can have more, that we can also give this economic opportunities to different regions depending on what richness in resources that they have, that they can build their economy around producing that type of SAF. That would be important to bring the new SAF, but as well other aspects is to reduce those technology once we have the project more mature, how we can reduce the technology risk so that it can go to the next stage, to the TRL, and then it can go to the more towards the commercialization. And here we see that this part is very critical, and maybe more targeted focus might be needed, because those the question is how far these technologies, when we look at the more most innovative and the sustainable one, like the eSAF, e-fuels for aviation, how far also they can, given their profile, risk profile and CapEx requirements, if they compete with other projects for other sectors, how they can also achieve the funding, how we can bring those actually to the market. So here is very important that the availability of the funding, but as well that they are tailored to support the project. Interesting as well components are the blended finance. So there we go to more mature projects, technological risk, so that like this investor are left or exposed rather with the commercial, and they don't need to take all, and the first loss can be absorbed and helping with de-risking. I also very much echo this cooperation across globe, as aviation is a global sector. So to move with the ambition globally, it's important as well that other sectors, cooperation, exchange of good practices, support. We are, I didn't elaborate on this, but we are under SAF, under ICAO, we are carrying out capacity building projects which help to build the policies, help with certification, but as well the exchange on R&I to actually help to bring the plants across the globe. Different regions will be very critical. So I think a lot of opportunities for R&I to support the.
Thank you. Thank you very much. There is a reaction from Kyriakos.
Not really reaction, but I mean, normally experience has shown that to take the value chains, for example, now the Icarus project is looking at, it takes approximately 10 to 15 years before they reach the maturity to be commercial. So that means that, let's say, the Icarus has to run for at least 3 years more, then we're about 2027, at least 5 to 8 years more, we're beyond 2030. So this kind of technologies, they're not going to do anything between now and for the targets of 2030, which means that most probably we're falling back to the main problem that we're going to rely in the near term for HEFA, or if there is a major breakthrough coming in. But I don't see any other major breakthrough coming. I mean, I don't know what's your experience because you follow international development and so on.
No, I think it's very clearly that the recent Sky Energy report very clearly showed that till the year 2030, it will all be based, well, let's say 90% it will be based on HEFA, and there will be some other fuels. But that market cannot continue based on used cooking oil and HEFA. We have to find the new technologies. And when you say it will take more than 10 years, and I'm afraid I have to agree with you, then we will face problems, yes, in the next decade. Anyhow, so technology development is crucial also for, let's say, our integrated biorefineries mission. We have also identified this, and also we also see opportunities for cost price reduction through this integrating approach. So looking at both bio-based chemicals and fuels and see how we can realize that jointly. And at this moment, we are also, let's say, doing a joint study with together with Canada and with Brazil. And I think there are similarities in what we try to achieve in bringing down costs and also what the Icarus project tries to achieve. And I think it will be interesting to see how we can collaborate more closely between these two projects. I think that would be interesting. And so Nassini, that's maybe we have to talk together another time, but I think that will be interesting. I see a hand from Prita. So Priti, you then you.
Thank you. Yeah, I think the point, thank you very much, Kees. The point which Kyriakos mentioned on, that life cycle of technology and life cycle of project, that is very important. I think for an industry who need each and every drop of SAF, I must say we should also, see what is available today, what are the low-hanging fruits. And in that direction, I must say the role of traditional energy companies is very important. Co-processing we already see, but at the same time at certain refineries, I come from energy industry and there are almost 600 plus refineries around the world. I know all of them can't do co-processing, but where it can be facilitated, we should take a deeper dive, how that can be facilitated. Second is, in US, we are already seeing that because of IRA, the existing renewable diesel facilities, for some of them, it makes case to swing towards higher production of SAF. So for the benefit of everybody, the renewable diesel facilities are producing renewable diesel today because incentives are in favor. But can we look into policy support so that these units can also produce higher fraction of SAF? Because as an aviation industry, we don't have anything except SAF. Whereas for road transport, you can bring in many other fuels. And last point in context of Europe there, I would say is, definitely biodiesel industry is great, but using that, lipid feedstock for biodiesel, probably we can start, looking into feedstock rationalization, that which industries are hard to decarbonize and where we need those feedstocks most. So I will leave that message on the table.
Thank you. Thank you. Thank you for that clear message about setting priorities in feedstocks, using the feedstocks. Maria, you have a remark.
Yes, being in the research and innovation and seeing these technologies being developed for many years and supporting technologies that perhaps become important, we don't know from now, in 2050. I can say that there are technology and research and innovation challenges continuously, even when something is established or claims to be mature and is established. So research and innovation will always be there to further improve a process, a value chain, all the parts of a technological pathway to produce a product, not only the SAF. This is equally happening for SAF. For example, the fact that we are opening now looking for bringing oil and lipids from degraded lands, from abandoned lands, or from contaminated lands. It's a matter of research and innovation that could expand the HEFA production, which HEFA is going to be there even in the longer term, but not as important as we see. But at least for Europe, we see that lignocellulosic feedstock becomes important over the years. So we need to mobilize this lignocellulosic feedstock and combine it with technologies and innovation in order to bring out the products. And we also see that we shift from road to aviation and shipping. And because the demand in 2030 for aviation and shipping is small, so you cannot expect that tomorrow the industry is building the plant for the years to come. So this will come gradually. What we need to be sure that we support is a smooth transition from road to aviation, and this needs research and innovation. And as Dr. Jane said, that we have markets that today, technologies that today produce renewable diesel, aviation, and maritime fuel at the same time. Even the Fischer-Tropsch, even the gasification, you have a range of these fuels that can be produced, and innovation there can help towards the one or the other direction, and that is also connected to the market. So if you do not have an outlet for your renewable diesel, you're not going to throw it or to convert it at an expense to aviation. This has to become, as the demand from the market changes, this has to be also smoothly follow the change of the demand and be able to respond to the market demand and make money. Mm-hmm. So research and innovation is particularly important there. If I have a better catalyst that does the isomerization and cracking, and I have, then this can help me to go from a gasification better to aviation. But this needs continuously efforts and money and support, even if now there is an STM for the Fischer-Tropsch for SAF, and we can say, okay, this is mature, we can go ahead, but at what cost?
Yeah. Okay. Yeah. Thank you very much for this remark, because it's really how we have to link innovation to markets. Yes, please.
Yes, thank you. Very, very interesting discussion. Another angle that could be useful also to discuss research and innovation policies to support staff.
And maybe you could introduce yourself to the people who are outside there.
Sure. I am Veronica Vouet, working for Total Energies in the refining and chemicals branch of Total Energy Strategy Division. Another angle that could help support the discussion to steer research and innovation policies for sustainable aviation fuel is to try to give a ranking of the merits of the various technologies, or more than technologies, value chain, i.e. combination of feedstock and technologies to produce a SAF, in terms of how much capex is needed to produce 1 unit of SAF, and how much energy, primary energy, will be needed to produce 1 unit of SAF. And with those kind of metrics in mind, it is challenging to understand the fundamental potential of hydrogen-derived fuels, because to produce hydrogen, you need a lot of energy. And then to further convert that hydrogen into a SAF fuel, i.e. combination of carbon and hydrogen that meets very stringent specification, it takes even more energy. RFNBO type SAF or eSAF is possibly up to 3 times the amount of energy that you'll find in this end product. You need to mobilize 3 times that amount of energy to produce it. So in a world that is not yet with excess energy, in particular renewable energy, it is important to think, I mean, which pathways, which technologies will support the most energy efficient, which at the end of the day should be cost efficient as well, and CO2 greenhouse gas, climate efficient technologies and pathways. It is probably an interesting consideration. And that would link up with Dr. Pretty Jane's remark on leveraging existing infrastructure and fuel producing and aviation fuel producing infrastructure. Probably leveraging those existing infrastructure can help smooth cost and energy cost. I mean, the economic cost and energy cost of the transition to produce more and more SAF. So possibly consideration to have in mind as well.
Thank you very much for your remark.
If I may complement, Mr. Webb, we think that if you combine RFNBOs with advanced biofuel production, utilizing the CO2, which is there as an effluent gas in the production of the biofuel, and recombine it, you can create, not that you can bring down the cost, but you can create synergies, and you can promote this eSAF more than if you had to get, I don't know, from direct air capture CO2 and then combine it with renewable hydrogen. Because also advanced biofuels need hydrogen, need renewable hydrogen if you want to increase the resource efficiency and produce more biofuel. So that type of synergies, perhaps, it's a matter of research and innovation to show whether they're cost-efficient solutions.
Okay, thank you very much. I think we are coming to the end also of this discussion. I know, Dr. Jane, you have to leave. I don't know if you want to make a final remark.
Yeah, sorry, I have another call at 1, but I think I must say, first of all, thanks for having us on this panel and represent from ITA. I just want to compliment the comment which came from Total. I think that's a very valid point, and that's where I think we need to start synergies to have energy companies and new players on the table, because many of these SAF units are not like traditional units, except for HEFA, which are huge 1 to 2 million ton kind of units. When we are talking about biomass and municipal solid waste, we all are cognizant of the fact that these are small units because of the biomass density and pelletization kind of challenge. These are very small units, going to be small distributed unit of production. So finding synergies to have a bolt-on kind of unit in the existing refineries or in the existing facilities can help us to meet that energy efficiency point which you highlighted. So I think we need to we need to learn by doing it, and more we collaborate, the better it is. Yeah. So thank you. Okay. I think I will, yeah.
Thank you very much. We have now, let's say, had a good discussion about the role of, let's say, research and innovation. It's crucial. That's what we learn. We also see that we need to do much more, because there will be a lot of new technologies are required for the next future. We will have to do that jointly, because it's a very big, let's say, effort. So this Icarus project, starting already on this, so I'm very grateful on that. And from, let's say, our integrated biorefineries mission, we will see also how we can collaborate on that. Policies are very much needed to make this happen. So we will now have lunch, and after lunch, we will then continue to discuss about the policies that will, can support this development of